So in our last session, what we have discussed is that what are the basic Git commands, the status command, the add command, how to commit something. Now I'll go a little bit more into depth, and we will look into how we can push code to GitHub. In the last session, what we have seen is that everything we were working was in a local folder. So if you remember, I had this folder uh, like temp git something like this, and here we did some work, and we that was local. After that, I also showed you how to create a GitHub account and how to create a repository from the GitHub web interface. And now what we want to do is that I want to upload some code inside this repository. So how can I add some code from the web interface? So now I'm going to explore the web interface a little bit. So if you go to this add file button, you can create a new file. And here, let me zoom it in a little bit. So you can just put any name to your file. So I want to give hello.py, a Python file. And here you can write some function, let's say, whatever you want to write. And so whatever code you want to write, you can write. And once you're done, you can click preview. Now this preview page will actually render the code in proper syntax, like in proper color coding. So if it's a HTML, CSS, JavaScript, all different languages, the standard languages, they are supported by GitHub. Now you can write the commit message, the commit heading, and then the extended detailed message. Now here, suppose if your GitHub account is connected with multiple email accounts, then you can choose which email account to use, and then you can finally commit. There are two options that you can commit directly to the main branch. So it will be a new commit to the main branch, or you can create a new branch. So I'll discuss the concept of branch later on, like just after this. But for now, let's say created new py file. So whatever meaningful, it should be meaningful for your team members, for whoever you're working with, and you can write some more description and you can just click commit. So this thing would create a new file. But for example, if the file with the same name already exists, you cannot create it. So I need to give some other name. So let's say I just do it hello2.py, right? So now I can commit it. So you cannot just create a new file with the same name. There's a problem. Okay. Okay. We have gone inside this hello.py. I think there is some issue here. Uh, so let me go back to this original, like the parent folder. I accidentally tried to create the file inside that folder. So hello.file is a file that already exists. I can click on the edit button to edit it. But what I want to do is that I want to create a new file. And you cannot create a new file with the same file name. That's one important thing. So when I create a new file, it should be of a different name. So let it be test.py. And here we can write some code. Let's say. So now I can commit it. So if I don't write any commit message, it will use the default one. So I can just directly click commit. So as you see, we have a new file test.py. So it's very simple. We can just create the add file, create new file, and by that we can create a new file. But suppose you want to upload files from your computer. Suppose you have already worked on a project and you want to upload multiple files. So I can just open my file browser. I can browse files, and let's say I want to go inside this temp folder, and let's say I have this, let's say some C code. I can just drag and drop it. So it is uploading. You can see this progress bar. So this file test5.c was uploaded. I can add multiple files. So I can select another file and upload it. So this new file was uploaded. So now I can write some message here. So added these files, and I can write more description if I want, and I can click on commit changes. So this was how we upload files from our local machine. So these new files, this test5.c, this was uploaded. So if I click on this file, I can see what's the code inside. Similarly, this verifier.py, this code also is uploaded. So like this, you can commit files, you can add files from the web interface, and you can also edit files from the web interface. Let's say I want to go into this verifier.py and I want to, let's say, make some changes. So without downloading this repository on your local machine, you can work everything from the web interface. So I can click on this pencil button. So this will open the editor. Okay, this will open the editor. So here I can add new line. So This is a new line that I'm adding, and I can write some commit message, and I can just directly commit it. So this is how we make a change to an already existing file. It's quite simple and quite intuitive. Once you see the interface, it will be quite simple. Now, if I want to see the history, I can see the entire history. So I created this hello file, then I created this test.py, then I added this files. This time I uploaded 2 files. So I can click on this commit and I can see what was done in this commit. So in this commit, I added these 2 files, right, with 21 additions, like 21 lines were added. So in this file there were 7 lines, and in this file there was 14 lines. So it is showing me 21 additions and 0 deletions. I did not delete any line, so that's why 0 deletions. So by now I think you are very quite familiar with this kind of interface, this split view of the changes, right? Now what I can do is that I can simply do one thing. I can if I want to clone this repository, there are multiple ways. This GitHub CLI method, I'll not discuss it now, but the standard methods that I'll discuss is the HTTPS and SSH. The git command already supports this HTTPS and SSH, and GitHub CLI is a different application. This is a command line application of GitHub, so it's created by GitHub. But we will discuss this HTTPS and SSH. Now, what is the HTTPS protocol? Via this protocol, you will have to enter your username and password. See, for a public repository, when you clone it, it's a public repository, for example, some public repository, you can clone it without needing a password. So even if you have not configured your Git, right, you can clone a public repository. So you just need to type this command git clone and then the URL of the repository. So let me just check, for example, if I just go to GitHub, C Python. This is a large repository. It will take probably a lot of time. Instead, let me try to clone some of my own small repo for just example purpose. So here I go. So let me find a small repo that I have. Okay, small repo. Yeah, this is a very small repository, only with a very few files. So it just has 2 files. So I can just click on this code button, and inside the HTTPS option, I can copy this link. So this link has been copied. See, one way is to download the zip. If you click on this download zip button, the zip file will be downloaded. It's very intuitive, right? You know what's a zip file. It's just packaged, and then you can extract the zip and the same story. But what we want to do is that we want to use the command line, and see, the zip thing will not download a Git repository. It will just download the project folder. That's it. But that is not Git version control. Zip is just for non-coders, people who are not coding, people who are, suppose someone wants to use a repository, they can download the zip and they can run the application like that. But for coders, the git command line should be used. So let me move into a new folder, test. Let me create a new folder for just doing all this stuff. And here inside this, I just run git clone, and if I just paste this URL, so this is the HTTPS URL, I paste it. So see, this is a public repository. Even if I do not have my Git configured with my credentials, it will be able to clone. You can clone a public repository without any issue. But suppose you are trying to clone some private repository, you can have the link of a private repository. I can give you the link, but unless and until you have the access rights, if you don't have the username and password, you cannot access. So when there is a private repository, you need the username and password. Now this thing is that you will be able to clone this, but you will not be able to push changes into this, right? If you just run the same command git clone, and after this URL, as this is my repository, only I am able to push changes. As you are not configured with my username, you do not have the permissions, you cannot push changes. So this is the security aspect of GitHub, right? Everybody has to can push changes only to their own account. So now if I want to authenticate myself via HTTPS, then it will just, when you just run the git clone command, it will ask you for a password, a username and a password. So to illustrate that, what I want to do is that let me one thing is that I can just create a Ubuntu server. So for the illustration of that git configuration, I will not go much deep into it because it will vary from system to system. So I don't want to show how to set up in Ubuntu, because somebody might be using Windows, the process might be different. You can just look that up, that credential, how to save that credential. See, every time you are not going to enter the password now. When you run the git clone some URL command, it will ask you for your username and password if it's a private repository. And even if it's not a private repository, it will be able to clone, but you will not be able to update it. You will not be able to push. You will not be able to run the push command, because if you don't have the access rights. So when you run the push command, suppose I have cloned this repository, right? I have let's say cloned this repository. So if I just run the ls command, I can see a new folder over here. I can move into this cd, I can move into this folder. Now I have rights because in my computer it's already configured, so I can push. But when you try to push, it will ask you for username and password. So every time entering username and password is difficult, right? So that's why you can save your username and password in a credential manager. That's it. There is nothing else into it. The concept is very simple. Instead of entering your username and password every time, it's just saved in your system. Now there is a much better way, a modern way, that is SSH, secure shell. So this kind of URL is SSH URL. So so there is a SSH key value, public key, private key thing. So that's a part of cryptography. I'm not going to discuss that cryptography thing here, but SSH is a recommended way. All companies actually enforce, a lot of companies actually enforce SSH. You are not recommended to use HTTPS because that's an old way of doing things. But yes, in certain use cases, HTTPS is also used. Now, if I just Google search GitHub setup SSH, so as simple as that. So connecting to GitHub with SSH, if you just open this documentation, so you will see how to generate an SSH key value pair. So this is the thing. The first article is about SSH. So this thing will explain you about SSH. So I want to read it a little bit. Using the SSH protocol, you can connect and authenticate to remote servers and services. With SSH keys, you can connect to GitHub without supplying your username and personal access token at each visit. You can also use an SSH to sign commits. So I will discuss this signing commits later. There are multiple ways you can use a SSH key or a GPG key to sign commits. Now, I'll discuss that later. What is signing commits? I'll discuss that later. But for now, let us talk about very simple thing. We are just trying to authenticate ourselves. So different repositories have different permissions, right? So if there is a private repository, everyone does not have access. Even if it is a private, public, suppose a repository is public, so you can download it, but you cannot modify it. Only the author of the repository or only the organization people, only people who have access to that, only they can change it. I and you cannot, we cannot change that until unless we are given the access, right? So that's the point you have to understand. Now, SSH is a protocol just like any other protocols. So over here you have a private key file on your local machine, and you supply the public key to the other party with whom you want to authenticate. So there is some cryptographic mathematics, some algorithm going on inside it, and that will verify. So that's it. So you have a private key on your machine. Like when you generate an SSH key, what happens is that a public key and a private key, a pair of keys is generated, right? So the public key, you have to upload it to GitHub, right? So here you can just read some basic stuff about SSH, but now here the interesting part comes: checking for existing SSH keys. Now this article, as you can see, you can select your OS. So this article is so good. They have given OS wise instructions. So if you're on Windows, click Windows. If you're on Linux, click Linux. So whatever is your operating system, you can select that. So by running this command, you can check whether you already have some existing SSH key or not. So I am on Linux. So what you have to do is that in Linux, all the SSH keys are stored in this .sh folder inside your root directory. So this tilde / means your root directory, then .sh. So this ls is just listing all files. So you will be listing all files. So this will list all the SSH key. Okay. So this is where the SSH keys are stored by default in the standard way. Obviously, you can configure your system to store it somewhere else. Everybody can do that. Like that's in Linux, everything is configurable, right? But it's a standard place where it's stored, right? So by running this ls command, you see what's there in your this .sh folder. By this, you can know whether you have an existing SSH key or not. Next thing is that generating a new SSH key and adding it to SSH agent. Now there is something called SSH agent that runs automatically in the background. Whenever you do a commit, like whenever you clone something, or it will on your behalf, it will provide you authentication. So something has to run on your machine, right? So when you run the git clone command, when you run some push command, so it has to authenticate every time, right? So that agent will do the work for you. So so how to generate a new SSH key? In Linux, there is this command. It's pre-installed. You don't have to install anything for this. If you just update your Ubuntu, you will get this thing. This is a pre-installed software. So SSH keygen. This command, keygen, means generate a key. And now this is the algorithm. There are multiple algorithms to generate SSH. Now in old systems, this RSA algorithm was used, and recently this ED25519 algorithm is used. I don't know how these algorithms work, but yes, these are some cryptographic algorithms. and you have to provide your email address also, the same email address that you have provided in your GitHub account. So then you can enter your file name, what file name you want to save it. You can put a passphrase. Passphrase means just a short password to protect it. So every time you want to commit, you have to, like, every time you use SSH, you have to type your passphrase. So this passphrase is for additional security. Passphrase is nothing like a password. So that's it. Now you have to add your SSH key to the SSH agent. So in Ubuntu, SSH agent automatically works. Now see, these systems are very different in Windows. It will be different, but no problem. You can just see the Windows documentation. You just click on Windows here. You can see the Windows documentation. The initial part is mostly same, and yeah, it looks same everything. I don't know why it's not showing. In Windows, I think they will instruct you to use git bash shell. There's like, just like you have the Windows PowerShell, that's the default shell in Windows. I think there is git bash shell, and yeah, exactly, that is what I predicted. Git bash. In Windows, you need to be on this shell. You cannot use the Windows PowerShell. A lot of these commands will not be in Windows PowerShell. You need to have this git bash shell. Okay, the git bash shell is just like bash, and inside git bash shell, the git is all pre-installed. So you just install git bash. That's it. And inside git bash shell, you can write Ubuntu commands, like the Linux commands are supported. Okay, and Linux, I think the Linux like file paths are also supported in git bash, most probably. So it gives you a Linux like experience, but you are on Windows actually. Right. So here is the process. First you generate the key, and then while generating the key, some prompts in the command line, some prompts will come. You will be asked to enter your file name, whatever. You can give any file name. So you should ideally name it my GitHub pass, my GitHub key, something like that. Some meaningful name you should give it, so that you can recognize it later on, like for what purpose you did. And then you have to add it to your SSH agent. That's it. So once that's done, what you need to do, the next thing is that so adding a new SSH key to your GitHub account. That's the next part. So in your GitHub account, you have to go to your settings page. Here you go on the top right, you click here and click in this top right, and then you go to your settings page. Inside settings page, here you can go to your this SSH and GPG keys, this section. You click here and you can add a new key. So I can see these are keys. Now this is the public part. This part you are seeing is not any secret. It's the public part. The secret part is not shown in the interface. Don't worry. So even if someone sees this code, they won't be able to hack my account or whatever. So these are the authentication keys that I have added in my system, and you can click on this new SSH key, and from your local machine you can copy that public key. So there is something.pub. So let me show you. Let me open my .sh folder. So here I have multiple SSH key pairs. So this is one pair, DigitalOcean.pub and DigiOcean. So DigitalOcean is a cloud platform where you can run servers basically. So I've used that. So for that, to authenticate into the server, my server, I use SSH keys. So this .pub is a public one that I need to upload it to DigitalOcean, and this simple one, like without the .pub, this is the private one. Similarly, this ID ed, this one is for my GitHub. This ID ed 25519.pub, this is for my GitHub account. And this file's known hosts is just a file that shows like to which IP addresses like I connected. It just saves them. So if I just show the node, this is an automatically generated file. It has some data, but it's automatically generated. You don't have to worry about it. And when you run the SSH keygen command, these two files will be generated, .pub file and this thing. I can just run cat id this .pub. So this is the SSH public key. That's it. You can just copy it and you can paste it. And you can click on add. You can give some title so that it's a memorable thing. You don't forget like which SSH. Suppose you are dealing with multiple SSH keys, then in that case, giving a proper title will be helpful in knowing what SSH key. So after that, you can test your SSH connection from your local machine. You just run one command to check whether connection to GitHub is successful or not. Now, once you have authenticated using SSH, what you can do is that you can download your own repositories and you can push to your repositories. You don't need to enter your password every time. That's it. Once you have set up your SSH, you don't need to use your password every time, right? And if you have the git bash shell, it's just very simple. If you have the git bash shell, you don't have to worry about git credential manager and other softwares. Just install the git bash shell. That will give you a ubuntu like experience inside Windows. But it's not VM, it's not slow, it's not like some VM is running on top. No, it's just directly on Windows. If you're using WSL is having its own file system, but git bash is just a shell. You will still have your Windows file system only. When you're opening git bash, you are having exact same files that you have on Windows. You're inside the Windows file system, you're exactly running on Windows, but the shell is actually git bash. That gives you like Ubuntu like experience. And also git bash shell comes with git and the other necessary softwares like this SSH keygen and blah blah blah. This kind of softwares are available, right? So that's the recommended way if you want to stay on Windows. But if you use Ubuntu on WSL, your file system will also get different. It will use a virtual file system on top of Windows. So that's kind of different. So this is how we set up this SSH. Once you have set up SSH, now you can just run the git push command and the code will get pushed to your account. And when you run the git clone command, if you are cloning a private repository, your private repository, that also will work without any issue. Now, the next thing that I want to talk about is, let's say I want to clone this particular repository. Let me clone this particular repository. For example, this tutorial repo. Let me open this tutorial repo. And if I click on this, I will get the SSH clone link. I can clone it. So in my test playground, let me just run git clone and the SSH URL. So this format of URL is for SSH. So git will understand that I am intending to authenticate via SSH, and obviously it will talk to the SSH agent and it will authenticate on behalf of me. And it's a private repository. As you can see, it's a private repository. This tutorial repo is a private repository, but as I have already set up my SSH, it is working perfectly fine, right? And another thing is that for your git commits, you need to set up your user information, right? So how to set up my email and name for git commits. So if you just search this, you will get this. The git config has two important configuration options, that is your name and your email, right? So git config global means it will apply for the entire user, like for your entire system. You can just put this user.email, this is the key, and then it's the value. So it's just a key value pair. So you just put your email. So every time you commit from your local machine, it will be committed with your email address, right? And where is this stored? There is a file called .gitconfig. So if I just do cat.gitconfig, so here it's stored. So over here, my editor is micro. It's a default editor that Git opens whenever I have to write some commit message or something. If I do not provide a commit message while running the command, it will automatically open my text editor and prompt me to write some commit message. So micro is set to my default text editor. And then there is something called auto CRLF. This is a quite interesting thing. CR stands for carriage return, LF stands for line feed. Now in Ubuntu, in Linux based systems, in Mac, what happens is that after a line ends, there is only a line feed. That's a new line. But in Windows, it's a new line and then it comes back to the previous position. There's something called carriage return. So you can just Google it up. What is CRLF? So it refers to the carriage return and line feed. So there is one good video about that. I forgot where is that video now, but there one public YouTube video is there. I'll give the link afterwards. So if you're on Ubuntu, you should give this to input. If you're on a Linux system, the configuration should be input. But if you're on Windows, I think it should be auto or input. It will automatically detect. See, what this does is that this option is great. Git automatically understands a file. If you are having a file on Windows, if you are working on a code file on Windows and you just directly take it to Ubuntu, there will be some issues, because in Ubuntu the encoding is a little different in Linux based systems. In text file, what happens is that at the end of every line, just line feed is there. But in Windows, their CR is there, like carriage return is there, and then line feed is there. So files a little bit different in Windows and Linux. So directly copying a file to another OS may lead to issues. That's why what Git does is that in Git there may be multiple users, like multiple users may be working on the same project, and different users may have different operating systems. And Git does not have any problem with that. It will automatically convert the types. So suppose you're a Windows user, when Git will download it from the central repository, in your machine it will convert into Windows format. And at the same time, suppose another Linux user is cloning that repository, Git will convert it to that format. So Git will automatically convert it to whatever format the OS is. So this auto CRLF option is input. You just write it input for Linux, and the option is I think different for Windows. You can just check it up. Now for the user, when I'll do commits, the username will be Anik, and this is my email ID, and I also sign every commit. For that I need a signing key. This is the public key for that, not the private one. And for every commit I use the GPG sign. This thing will be set to true. Now what is signing commits, that I'll discuss later on. That's currently not important, but I'll discuss that later on. But this is the basic thing. Like when you do the git config and global username, when you set your username, when you run this command, what happens is that whatever you enter, that gets saved into this git config file, right? Now what does global mean is that global means for all repositories, for all git projects inside your system. But suppose some at particular point of time you want to have a different configuration for a particular project. For a particular project you want some different configuration. For that you can specifically set an email address for a single repository. So for a single repository you can go there and you can just configure it per repository. That's our option available. This global will set it for all repositories you create inside that system. That's it. So by this you can set up your SSH, and once that's done, what you can do is that you can push code. You can clone and we can push code. So I have shown how to edit from the GitHub web interface that I've already shown. Now from the terminal here, let me go to this thing. So I have this folder tutorial repo. So this tutorial repo initially worked from the GitHub web interface. Now I have cloned it locally, right? Now from locally I want to make some changes. Yes, I can do it. So somebody may have created this repo instead of me. Somebody else may have created this repo. Now as I have permission, I have cloned it. Now I want to edit some files. So let me open, let's say let me open VS Code inside this folder. I click this and here let me add a new file. So let me add new.py and let me just write some comment. That's it. Now I can commit this. I can just add this from the VS Code interface. I can just directly add it. I can write some comment message and I can commit it. Now from VS Code I have this option, like from bottom I have this option to push this commit to the origin. Origin means the actual repository. Now from the command line also I can do it. I can just run the git push command. So if I just do the git push command, it will push to origin. So from my local main to that remote main, it was pushed. Now if I open my web interface, if I refresh this page once, I can see that just now this just a second. Just now this new file has been added. It's showing now. The time is now, right? So from local machine I am pushing something, right? That is something what we can do. It's quite simple. You clone the repository first by using the git clone command. In the local machine, you open your code editor, you edit it, you git commit. After git commit, you git push. That's it. And suppose the file is untracked. In that case, you have to add the file. So from the VS Code interface also I have shown, you can just click the plus button beside the file, or from the command line terminal, you can just do git add. You can add specific files by git add the file name, or you can add all the files, git add then dot. That's it. This is how you push to GitHub. Now there are a lot of other topics, but this is the main crux. Like this is the flow that we need to follow. But the flow will be a little different. Suppose if the repository does not exist in GitHub, suppose you create the repository locally first, and then you want to push. There's some commands you have to learn. But what we do is that generally what people do is that they open the GitHub web interface. They open the GitHub web interface and then they create a repository. One good thing is that GitHub will provide you with license file. You can just select a license file and will provide you with license file, the readme file. That's it. And you create a repository from the web interface. Then you clone it. You should have your SSH set up in your system. You clone it after cloning it, you open your code editor, you change some files, and then you commit and you push. That's it. That's a standard flow. There are different flows also. Like this, there can be a case when the repository does not exist on GitHub. You just start it from local, and yes, after that also you can push it to GitHub. That's also possible. You have to create the remote. That's possible. Another thing is that you can create an empty repository on GitHub. On GitHub, you create a repo, but there is no files in it. It's completely empty. In that case, you have to set up certain things locally. So in those cases, there's some extra additional lines of command you have to write. But those flows I'm not discussing. Otherwise, the video will get longer. But the standard flow by which we can work is that it's very simple. From the web interface of GitHub, create a repository. Then you clone it, but make sure you have SSH configured. That's the most secure way. In Windows, you should have Git Bash installed, and after that, after locally editing the files, so inside the local folder you can add more files and then you can push it. That's it. Or another thing is that to initialize the repository for the first commit, what you can do is that you can just drag and drop the files. So what you can do is that you can create an empty repository. Let me show this way also. Let me create an empty repository. So here I go. I click on new. So some name. So let me make it a private repo, and I am creating a empty repository. I'm not adding any readme, I'm not adding any git ignore, I'm not adding any license. So if I just, without selecting anything, if I just create repository, what will happen is that it will be a completely empty repository. I don't know why internet connection is so bad. Like every time this site can be reaches. I don't know what happened to my internet, but unfortunately, let me say what I was trying to say. You create an empty repository. After that, GitHub will only show what commands to run. In the interface only, it will show how you can push the first file to your empty repository. Right. Otherwise, what you can do is that you can use the web interface. You can just drag and drop some files. The initial files you can drag and drop, and after that, other members of the team can clone the repository and make changes. Now, I did not discuss about making branches. Making branches is quite simple. So in your local machine, you just run the git branch command. Right, and when you do the git branch and when you push the branch inside the GitHub web interface, there will be an option. It will prompt you to create a pull request. It will just show, or you can just go to the pull requests tab and create a new pull request. That option will come. A pull request is nothing but it's a request to the maintainer to merge your code. So instead of directly writing on the main, that's the point. If you see main, in the main branch, what happens is that there's running on the production, there's running actual code. So instead of writing your code in the main, what you do is that you create a separate branch, you write the code there, and then you request for a pull. Then other people in the team will review your code, and then it will be merged. When merge is clicked, it will get merged. That's the thing. Now, all these things are quite simple, but unfortunately, I have to stop the session now. I don't know why my internet is not working. This page is not opening. So for now, let's keep the session short and just